Hi, in this problem we'll be looking at the PDF of the absolute value of x. So if we know a random variable x and we know its PDF, how can we use that information to help us find the PDF of another random variable, the absolute value of x? And so throughout this problem we'll define a new random variable called y, and we'll define that y to be equal to the absolute value of x, just to make things simpler. So we'll do a couple of concrete examples, and then we'll try to generalize at the end. The first example that we deal with in part A is this PDF for x. So we're told that the PDF of x is 1/3 between -2 and 1, and it's 0 otherwise. And here's a picture of what it looks like. It's just a rectangle from -2 to 1. So now we want to find out what is the PDF of the absolute value of x, which we've called y. And at this point, it may be helpful to step back and think about this problem from the discrete point of view again. So if x were a discrete random variable, you could say the problem would be, what is the probability that the absolute value of x is equal to, say, 1/2? Well, the probability that the absolute value of x is equal to 1/2, that can occur in two different ways. One is that x itself is 1/2, or x could be -1/2, in which case the absolute value of x would still be 1/2. And so those two events are mutually exclusive. And so the probability of either one of them happening is you can just add them up. And so the probability of the absolute value of x being 1/2 would just have two contributions, one from x being 1/2 and one from x being -1/2. And so the same idea, the analogous idea carries over to the continuous case when you have a PDF. So now let's say that we're interested in the case where we want to know the PDF of y at 1/2. Well, that again is going to have two contributions. One from where x is 1/2, and one from where x is -1/2. And so you can just imagine that each one of these values for y, and remember y has to be non-negative because it's an absolute value, has two contributions. One from the right side of 0, and one from the left or negative side of 0. So you can come up and write a algebraic expression for this, and we'll do that in part C. But you can also look at this from a visual point of view. And you can take the PDF diagram itself and imagine transforming it to find out what the PDF of the absolute value of x will look like. So the way to do it would be you take what's left, what's on the negative side, you flip it over and take the mirror image, and then you stack it on top of what you have on the right-hand side or the positive side. So take this, flip it over, and stack it on top. You can imagine just taking this block, flipping it over, and just think of it as kind of like a Tetris block that's falling down from above, and it stacks on top of wherever it lands. So it'll turn into something that looks like this. So there's already a block of height 1/3 from 0 to 1. And that's from the original one. And now we take this and flip it over and drop it on top. Well, this part is going to fall on top of the segment from 0 to 1. And then this part gets flipped over and dropped over here, and it falls down here. And so the final PDF actually looks like this kind of staircase, where this is 2/3 now because it has two contributions of 1/3 each, and this is 1/3. All right, so that is the kind of graphical way of approaching this. And the PDF for completeness, the PDF of y would be 2/3 for y between 0 and 1, 1/3 for y from 1 to 2, and 0 otherwise. All right, so let's move on to part B and get some more practice. Part B, we're given that this PDF of x now is 2 times e to the negative 2x for x positive and 0 otherwise. Now you may just recognize this as just an exponential random variable with a parameter of 2. And again, we can graph this and see what it looks like. And it turns out that it's going to start out at 2 and fall off exponentially. So in this case, this is actually quite simple because if you look at it, x is already positive. It doesn't have any negative parts. So in fact, the absolute value of x is the same as x itself because x is never negative. And so y is just the same thing as x. And so in this case, actually, the PDF of y is exactly the same as a PDF of x. It's just 2e to the minus 2y for y positive and 0 otherwise. Now you can also see this because, just graphically also, because to the left of 0, the negative part, there is no PDF. The PDF is 0. And so if you were to take this, flip it over and drop it on top, you wouldn't get anything, right? Because there's nothing there. And so the entire PDF, even after you take the absolute value, is just the original one. So to generalize, what I said in the beginning was that, remember, the probability in the discrete case, you had that if you wanted the probability that the absolute value of a random variable equals something, that would just be the probability that the random variable equals that value of little x, or the random variable equals negative little x. Right? In either of those two cases, the absolute value would equal x. So you get those two contributions. And so to generalize in the continuous case with PDFs, you get something that looks very similar. So in this case, the PDF of y is just the PDF of x at y. So this is the case where x is just equal to y, plus the PDF of x evaluated at negative y. So you again have both of these two contributions. And we can rewrite this top one to make it look more similar. So the PMF of some discrete random variable y, where this is a discrete random variable that's equal to the absolute value of x, would be the PMF of x evaluated at y plus the PMF of x evaluated at negative y. So in both the discrete and continuous cases, you have the same thing. Okay, so the overall summary of this problem is that when you take a transformation, in this case an absolute value, you can reason about it and figure out how to decompose that into arguments about the original random variable, just plain old x. And for the specific case of the absolute value, it just becomes taking sort of a mirror image and plopping it on top of what you originally had. So remember, you always have these two contributions. And so if you ever have a random variable that you need to take an absolute value of, you don't have to be scared. All you have to do is consider both of these contributions and add them up, and you have the PDF that you want. Okay, so we'll see you next time.